Okay, so today we'll be covering about this alternative drives for automotives. Okay, see, if I'm talking about the current scenario, then in the current scenario, what is the prime requirement? The prime requirement from all the customers is that the vehicle should operate on very low cost. That is the prime requirement. Why? Because the fuel prices, they have increased a lot. Second of all, the conventional fuels, they are depleting. Okay, so we do not have much reserves left for the conventional fuels also. Okay, and most important is the environmental conditions. As we know that in today's time, the environment has degraded a lot. Okay, it's because of the pollution, and the pollution, it can come from the vehicles also. Not only from vehicles, it can come from various industries. It comes from automotive, it comes from agricultural industries, it comes from your basic manufacturing industries and so on. But still, what we know is that automotives, they are also a major polluter for the environment. Okay, so keeping this in mind, what we have done is we are trying to find out the ways by which we can drive the vehicles. Okay, so in this presentation, I will be covering about the electric vehicles. I will be covering about the hybrid electric vehicles. Okay. Now, this will be the content that I'll be discussing about the problem. First of all, that why do we require to switch over to the alternative drives? Then what are the developments which we have done? And the brief history for the electric vehicle. I hope you all know that electric vehicle, it is not a newer technology. Okay, it was invented way back in 1800s. So it's not a new technology, but at that time, the sale for the electric vehicles, that was very less, and the IC engines, they have surpassed that the sale of electric vehicles. Okay, then we'll be discussing about the basic advantages of electric vehicles, battery electric vehicles or hybrid electric vehicles. Then what are the challenges right now, and how we can meet those challenges. So this all we will be covering in this presentation. Okay, so first of all, as I have told you, that why do we require the alternative drive? Okay, the answer for that is, you all know, the major reason is pollution. What we have to do is we have to lower down the pollution. Okay, this data I have taken from the for California. But if I talk about the Indian scenario also, then in India also, according to this study which was conducted by IIT Kanpur, according to their study, they found out that the automotives, they are responsible for 28% of the total pollution which is caused. Okay, and that is the very big number. Okay, though in India, what we are having is we are having the density of two-wheelers is more, while the density of four-wheelers, that is the passengers car, is less. So what I can say is that India is the two-wheeler oriented country, in which the density of two-wheelers are more than that of the passenger cars. Okay, so keeping this in mind itself, what the Indian government has done is they have skipped the BS5 norms. They have shifted directly towards the BS6 norms. But if I talk about these norms also, if in India, what we are having is we're having the BS norms. If I talk about these BS norms also, this BS, it stands for Bharat Stage. BS, it stands for Bharat Stage. This is the pollution norms for the automotives, at how much pollution a vehicle can produce. Okay, this is implemented to safeguard the environment. Okay, so these pollution norms in India, they were implemented in 1997. But in 1997, these BS norms, they were limited to the metro cities of India itself. Okay, but in the year 2000, these BS norms, they were they were made mandatory pan India. Okay, so that was the BS1 stage. So if I talk about BS1, 2, 3, 4, and 6, I'm not adding 5 because 5 we have skipped. But if I talk about these norms from 1 to 6, then in that case, before this BS6 norms came into place, Before that, what was happening, that the norms were different for different vehicles. I hope you people are getting my point. When I'm talking about BS1 to BS6, then in that BS1 to BS4, skip BS6 right now. But when I'm talking about BS1 to BS4, in that scenario, what has actually happened is that the norms, they were different for different vehicles. That is, the passenger cars, they were having different pollution norms. For the commercial vehicles, you were having different pollution norms, and for two-wheelers, you were having different pollution norms. Okay, so because of this reason itself, the level of the pollution, it cannot be lowered down from the vehicles. But when we have came down to BS6, so what the Indian government has done now is they have implemented BS6 norms in April 2020. That is, from 1st April 2020, all the vehicles which are coming, they are BS6 vehicles. Okay, so what the Indian government has done is that they have made these laws universal for all the categories of vehicles. Okay, and the category includes two-wheelers, four-wheelers, and commercial vehicles. So we have taken three categories of the vehicles: two-wheelers, four-wheelers, and the commercial vehicles, in which what we have done is we have implemented these BS norms. Okay, so right now all the vehicles which are coming in this category, they are following BS6 norms. So when we are going from one norm to another norm, then in that case, what we are doing is we are making the pollution norms more stricter. Okay, and when we are changing the pollution norms, so in that case, what the manufacturing companies have to do, manufacturing companies have to change their technology also. That is, in the earlier generation of vehicles, you were having carburetors in place. So the carburetors were responsible for supplying air and fuel mixture into the combustion chamber in case of SI engines. While in the case of diesel engines, what we were having this mechanical fuel pumps and the mechanical injectors, which were responsible for the supply of fuel into the combustion chamber. In case of CI engines, that is the diesel engines. Okay, now when we have shifted from one norm to another, then in that case, for the petrol engines, what we have done is we have skipped that carburetor and we have shifted towards the fuel injection system. While in the case of diesel engines, what we have done is we have shifted from mechanical fuel pumps and the mechanical injectors from the electric fuel pumps and the electronic injectors. Okay, so what we have done is we have implemented the newer technology into the automotive so that the performance of the automotive, it can be optimized, and second, the pollution which is coming out from the tailpipe, it can also be lowered down. But when we are shifting from one technology to the another technology, then in that case, obviously what will happen, the cost of the vehicle will go up. So that is also a major problem, that if we are making the vehicles according to the pollution norms, then because of that, obviously what is happening, the cost of vehicles is going up. I'm not going very behind. I'm coming on to this, 2020 itself, when this BS6 norms were, they were enforced in India. Then in that case, I hope you people have heard that the various automotive manufacturers, what they have said is they have told that they will not be manufacturing smaller diesel engines now. Why? Because the cost of smaller diesel engine, it will increase near about 1,25,000 to 1,50,000, and the customer will not pay for that. Secondly, what the government has done, government has also reduced the life of diesel engine from 15 years to 10 years. Okay, so this was the, because of these two reasons itself, what they have done is they have started, they've stopped the production of the smaller diesel engines. Now the big diesel engines are coming of 2,000 liter, of 2 liter, or more than 2 liter capacity. Those, diesel engines are coming. Okay. Now, that was the one problem which the company have solved, that they will not be manufacturing the diesel engines. Now, another problem which has came this year itself, from February 2022, when Russia invaded Ukraine, and in that case, there was the fuel crisis all over the world, and because of that, I hope you people have seen that the fuel prices have, they have hiked up to rupees 10-15 rupees per liter. Okay, so because of that, actually, what is happening, the sale of the vehicles, it has come down. Okay, so for that, what the companies are now planning is companies are now planning to make the vehicles which have low operating and maintenance cost, and that is the prime demand. And secondly, what they are trying to do is they're trying to make the vehicles which produces very less pollution or zero pollution. So for this, the hybrid vehicles and the battery electric vehicles, they serve a very important role. Okay, and moreover, I'll just tell you one thing. Right now, we are in the first phase of pollution norms. Okay, that is we are into the BS6 norms, but that is the first phase of BS6 norms. In the second phase of BS6 norms, which were supposed to be launched this year itself in 2022, but because of this COVID and all, the government has they have postponed that second phase. Okay, so according to the second phase, the government, they are introducing one more thing over here, and that is CAFE. So CAFE stands for Corporate Average Fuel Economy. Okay, and that will play a very important role in reducing the cost of the vehicles also. Okay, so in the second phase of BS6 norm, these CAFE, it will be introduced. That is the Corporate Average Fuel Economy. So suppose if I talk about a particular company, and that is Maruti Suzuki. So if I'm talking about the Maruti Suzuki, so the Maruti Suzuki, they're having 7 to 8 vehicles right now. So what the government will do, the government will take the average of the fuel economy for all the cars they are having. So suppose they're having 7 to 8 models, and each model is having its dedicated fuel economy. So what they will do is they will make the average of all the fuel economies, and in that proportion itself, the government will give some benefits to the corporates. Okay, and when the government will provide the benefit to the corporates, then obviously what will happen? The cost of the vehicle will come down. Okay, so the end user, so end user has to pay little bit less amount for purchasing a vehicle. Okay, so how we can increase the average of the vehicle? How we can increase the average of the vehicle? That is how we can increase the fuel economy of the vehicle. That is the basic challenge. Okay, so how we can do that? By changing the fuel technology. So we have done that, and we are working on that also. Okay, it's not like that the IC engine based vehicles are obsolete from the market. They are still running in the market with full efficiency, but still, how we can increase the fuel economy? We can increase the fuel economy by changing the fuel induction method into the combustion chamber. That is the one way. Okay, second, we can introduce more CNG vehicles. That is, right now, the common practice is that we have either got the petrol engine or the diesel engine. Now, each and every company, they're planning to launch their CNG vehicles also. Earlier, Maruti Suzuki and Hyundai were having their CNG range. But right now, I hope you know that Tata Motors, they have also introduced their CNG range in Tata Tiago and Tigor. Okay, that is based on intelligent CNG technology. Okay, Kia Motors, they are also planning to launch Sonet in CNG. Okay, so they're introducing the CNG range also. So when they will go into the CNG range, that is also the alternative source to drive the engine. So when they're going on to the CNG range, then in that case, obviously the mileage of the vehicle will go up, the maintenance cost and the running cost, it will also come down. So it will give some relief to the customers. Next, what the companies are planning to do is each and every company right now, they're working on the production of pure electric vehicles. They're not working on hybrid vehicles anymore. I don't know that why they're not working on the hybrid vehicles. The reason can be the engine itself, that they want to obsolete the IC engine. But the companies are working on the electric vehicles also. And each and every day, a newer electrical vehicle is coming into the market. Okay, as I have already mentioned that India, it is two-wheeler oriented country. So in that case, you can see that there are n number of companies in the market which have launched their two-wheelers. Okay, if I talk about the four-wheelers, right now the four-wheeler is less. Okay, Tata Motors, they are producing their electric vehicle, that is Tigor EV and Nexon EV. Nexon electric vehicle. It is the great success. Okay, then Hyundai is having their electric vehicle, that is Kona, but the cost of that vehicle is very high. Okay, so this is the range. Okay, MG is also having their electric vehicle, but again, there are some challenges in the electric vehicles also that we'll discuss in the later slides. Okay, so now with this slide, what I want to say is that how this need has occurred. Why do we require to switch from the conventional vehicles to the electric or the hybrid vehicles? The need is that what we want is we want low operating and running cost. We want less pollution in the environment, so that the vehicles can obey the norms which have been issued by the government. And in near future, these norms, they will get more strict. Okay, and obviously we have to lower down the pollution. That is the prime aim of the of Indian government right now. When we have signed this when we have signed the Paris Convention, then in that case, India has promised that they will reduce their carbon dioxide emissions by half up to 2030. So 2030, it's not possible, but up to 2035 or 2040, we will be reducing our this carbon dioxide emissions by half. Okay, India, as we are the developing country, many industries are coming into the Indian market. So because of that, the level of pollution right now is very high. But once all the things will be stabilized, then obviously the level of pollution in the environment will automatically come down. And that is the prime requirement right now, because right now, if I talk about the climatic changes, in May, we are having the temperature of 48 degrees centigrade in some parts of northern India. And that is the very alarming situation. I hope this thing is clear to all. Okay, so for this, what we have developed is, that is, we are going from one millennium to the other millennium. Okay, we are having the conventional IC engine based vehicles, and from those conventional IC engine based vehicles, we are going into the new era of the automotives, and that can be the electric vehicles or the hybrid electric vehicles or the fuel cell vehicles also. Okay, so what are the major reasons for that? First of all, the pollution. Second reason is the global warming. And third reason is oil shortage. And we have seen this oil shortage, from February also. Okay, if I talk about the European countries, they're having they are left with very less oil reserves, because Russia is not supplying their oil to European countries. Okay, European countries, they're dependent on Russia for oil and gas. So in near future, what can happen? That this shortage, it can increase. And when the shortage will increase and demand will rise, then obviously what will happen? The cost of the conventional fuel will also increase. Okay. Next, for that, what we have done is, these concerns only, they have led to the development of electric vehicles or HEVs, that is the hybrid electric vehicles. Okay, but what we are having is, we are having certain limitations also. So if I talk about the pure electric vehicles, the major limitation is the range. Okay, if I talk about India, then we are not having sufficient infrastructure available in India. Okay, charging infrastructure is not available. So that is why people are not buying electric vehicles. Okay, if you have to travel from if you have to travel for longer distances, then right now electric vehicles, they are not the correct choice. Okay, because we cannot charge the electric vehicle using the household supply. It will take near about 8 to 10 hours for the charging purpose. Okay, and that is not desirable right now. In the four-wheeler market, the penetration of electric vehicles, okay, it is very less. But if I talk about the two-wheelers, so when I'm talking about the two-wheelers, so two-wheelers, they are the people travel at an average distance of 15-20 kilometers in a day, or it can be 30-40 kilometers also. So they're having that range also. Okay, and you can easily charge your two-wheelers at your home also. So that is why the penetration of electric two-wheelers are more, but the penetration of four-wheelers are less. And but the one reason for that is the range. Okay, second is the cost of battery. The cost of battery is very high right now. Okay, we are also working on the newer battery materials. Right now, we are dependent on other countries for the supply of lithium, as we are having the lithium-ion batteries itself. So that is why the cost of the batteries are very high. So that is the also challenge for the electric vehicles. Okay, so because the electric vehicles are having these challenges, that is why the second technology which we can have to drive the vehicle is the hybrid electric. So the hybrid electrical vehicle will be a vehicle which will be having two power sources. Okay, so the one power source will be engine, the second power source will be electric motor. So with the help of those two power sources, what we can have is we can drive the engine. Okay, and when I'm having two power sources, then obviously, the fuel consumption from the IC engine will reduce. Okay, I can explain it with the example also. Suppose I'm constructing a wall. Okay, if I will construct that wall alone, then I can take 2 days or 3 days for the completion of work. But if I get the helper, okay, or someone is okay, my friend is also helping in constructing that wall, then obviously the construction of that wall will finish in half amount of time. So what we have done is we have divided the work. Okay, the efforts have been divided. So similar kind of thing happens in the hybrid electric vehicles also. So what we have done is we have divided the work between the engine and the motor. Okay, so with the help of both, what we can do is we can drive the vehicle. Okay, and if I'm talking about the hybrid electric vehicle, it will operate on two sources, that is the engine and the electric motor. So obviously what will happen, obviously, the range limitation, it will not work in this hybrid electric vehicle technology. What are the advantages? So it contains both parts, as I have told you. It contains it constitutes the gasoline and the electric motors. Okay, the power range, cost, and safety, it is equivalent to the normal conventional car. Okay, so the battery, it can be continuously charged on board also. So what we are having is we are having motor cum generator for this purpose, so that the battery can be charged. So these are the kind of electric vehicles. We are having the locomotives, golf carts, forklifts, some electric buses are also there, nuclear submarines, and the elevators. They are the kind of electric vehicles which we are having. If I talk about the submarines also, so when the submarine is underwater, and it runs with the help of battery power. Okay, it takes the current from the battery. But when it is onto the surface, then in that case, it uses the engine to operate. Okay, so that is the kind of hybrid vehicle itself. Because on that also, what we are having is we are having two power sources available. Okay, if I talk about the electric buses, so the electric buses which we are having right now, they are the pure electric buses. Okay, and in FAME 2 scheme of Indian government, that is faster adoption and manufacturing of electric vehicles, many cities of India, they're having the electric bus. They're operating the electric buses in this scheme itself. If you talk about the cars, so we've got the hydrogen fuel cell car, we've got the solar cars also, the hybrid vehicles are also there, and the complete electric vehicle is also in place. Okay, so we are having all types of vehicles available, but still the rate of adoption for these vehicles are less than that of the conventional IC engine based vehicles. Okay, there are two reasons for that. First of all the consumer, they doesn't know about the technology of hybrid vehicles. Okay, and second, if I talk about the battery electric vehicles, and in that case, range is the major problem. Okay, if I talk about the history of the electric vehicles, as I have told you that the electric vehicles, they have evolved in the beginning of 1800 itself. So in 1830, the first electric vehicle was, it was manufactured. Okay, till 1890s, what was happening? The EVs, they were more, if I'm comparing it with the conventional vehicles. But as the time passed, when the people start to commute towards longer distances, then because of that, actually what has happened, the demand of electric vehicles from the market, it has come down. Okay, and the IC engine has taken the place, because with the help of IC engine, what we can do is what we have to do is we have to fill the fuel, and then we have to commute from one place to another. And filling the fuel, it hardly take 5 minutes. If I'm having pure electric vehicle and if I'm at the charging station, so right now we need to have near about 1.5 hours for 80% charging. Okay, and the time is very high right now. So what is an electric vehicle? Electric vehicle, if I'm talking about the electric vehicles, then we have got different types of electric vehicles. What we are having is, first of all, we are having the hybrid vehicles. Then we are having the plug-in hybrid electric vehicles. Then we are having battery electric vehicles. And lastly, we are having the fuel cell vehicles. Okay, so if I'm talking about the electric vehicles, in the electric vehicle, what we will be having? We'll be having a motor. We will be having a generator. If I'm talking about the hybrid, we'll be having a generator also. So if I talk about the major components, what components we are having? If I talk about full electric, if I talk about full electric vehicle, then the major component will be motor. It can be AC synchronous motor, which operates from 60 volts to 72 volts. It depends on to the manufacturer, which type of motor they are using. Then we are having battery pack. So we are having the huge battery pack available under the body of the car, which will supply the current to the electric motor. Then what we will be having the BMS, that is the battery management system, which will help in the efficient charging and discharging of the battery, which will help in maintaining the temperature of the battery. So that is the full, that these parts are for the full electric vehicles. If I'm talking about the hybrid vehicles, then in the case of hybrid vehicles, what we are having, we'll be having IC engine, we'll be having motor, come generator. In the case of hybrid vehicles, what we are having is we are having ISG. ISG stands for integrated starter and generator. Okay. Then we're having the power split devices. Then we are also having the battery packs available. This battery pack is for the motor. Then at last we are having the regenerative braking system also. Okay, so these all components will be present in the hybrid vehicles. Okay. So here you can see that if I talk about the conventional vehicles, so what we have to do is you have to induce the fuel into the engine, and engine, it will produce the power for us that will be transferred to the transmission system, and with the help of transmission system we can split it into the wheels so that the vehicle can drive. Next comes the hybrid vehicle, in which what we will be having, a battery. This battery will be solely responsible for supplying the current into the motor or generator part, that I have told you it is ISG. ISG, that is integrated starter and generator. So onto the hybrid vehicles, keep one thing in mind, that we will be having two battery sources available. One battery, that will be a 12-volt battery, which will be present for the IC engine, while the second one will be lithium-ion battery pack, which will be present for the motor available onto the vehicle, which ranges from 60 volts to 72 volts. Then what we are having the battery electric vehicles. So for the battery electric vehicles, what we will be having, a battery pack. We are having the motor generator in place, because in the case of electrical vehicles, what we are having is we're having the regenerative braking system also. So when I'm talking about the regenerative braking system, in that we have to use a motor which can actually work as a generator also. Okay, so that is known as integrated starter and generator, which I have told you earlier in the case of hybrid vehicles also. And then we'll be having a transmission by which the power will be divided into the wheels and the vehicle can control. So this is the electrification which we have done into the vehicles. Okay, so I've compared all the vehicles, that is the conventional, hybrid, and the battery electric vehicles over there. Okay, now I've made a graph also over that, you know, when I'm going to make something newer, and in that case, always what I have to do is I have to compare my invention from the previous inventions which have been made. Okay, so here the previous technology what we were having is we were having the conventional engines. In the conventional engines also we are having two categories of engines. Just forget about SI and CI engines. They've got two categories of engines, and those two categories are NA, that is naturally aspirated. I hope you people know about that. The first one is naturally aspirated engines, in which the air, it is induced at the pressure just above the atmospheric pressure. Okay, so what the engine will do, engine will suck the air from the atmosphere. Air in the atmosphere, it is present at 1 bar pressure. It will come into the system where this pressure will increase little bit. Okay, and then it will be supplied into the combustion chamber. Next is the turbocharged engines. So in the turbocharged engines, what will happen? That the engine, it will take the system, air intake system, it will take the air from the atmosphere at 1 bar pressure, and then that air will go into the turbocharger, where the pressure of this air will increase, and then it will be transferred into the combustion chamber so that the combustion process can begin. Because of the high pressure, the volumetric efficiency of the engine can be increased. And because the volumetric efficiency is increased, then obviously what will happen, the power output and the initial torque coming out from the engine, it will also increase. So here, what I have done is I have taken four categories. The first one is the hybrid drive. Second is the IC engine drive. So IC engine, it is the 1.6 liter IC engine, that is naturally aspirated engine. Next is the turbocharged engine, okay, which is 1.2 liter. And then the fourth one is for the electrical machine, that can be electric vehicle, okay, which is having 15 kilowatt of motor. Okay, so I've taken four vehicles over there. The first one is the hybrid drive. Second one is the IC engine based vehicle. Third one is the turbocharged engine. And fourth one is the electrical vehicle. Now from this graph, which I have made between the torque and the engine speed, you can see that if I'm talking about the hybrid vehicle, it is producing very high amount of torque initially, which we require. And then the torque decreases gradually. Okay, because what we have to do is have to then increase the speed of the vehicle. Then obviously what will happen, the torque will decrease. Okay, if I'm comparing it with the IC engines, that is the naturally aspirated IC engine and the turbocharged IC engine, in that case what you are seeing is that if I'm comparing with the torque and the engine speed, then the performance is little bit similar. The performance, it is little bit similar when the graph is being plotted between the torque and the engine speed. Next comes the electric vehicles. So the pure electric vehicles, what they're doing is they're giving high torque at the initial point, which is required for bringing the vehicle from rest position to motion position, and then the torque level, it is little bit maintained, and then it decreases gradually. So what you can see over here is that the electric motor, it works near about as same as that of the conventional electric motor. Now, if I talk about the advantages of advantages of having the hybrid drive into the vehicles, that is, obviously in the case of hybrid electric vehicles, what has happened, the work of engine and the motor, it has been distributed. So in some cases, in some of the electrical vehicles, what will be happening, the engine and the motor, they both will be driving the vehicle. So what will happen, the work between the two will be divided. So obviously what will happen, the engine, it will consume less amount of fuel. We can downsize the engine also. So when we are downsizing the engine, then in that case, what will actually happen, the fuel consumption by the smaller size engine will be less, and when the fuel consumption will be less, then obviously what will happen, the pollution coming out from the tailpipe, it will also be reduced. Next, with the help of hybrid electrical vehicles, what we are getting is, we are getting the very high torque range. Why? Because here the motor and the engine both can work together to produce the required torque, so that the vehicle can be accelerated at a very faster rate. So these are the advantages of having the hybrid electric drives into the vehicle. Okay, now we are having the degree of hybridization also. We're having the degree of hybridization also. Just remember one thing, which I have talked in the earlier slide, and that was the CAFE norm. I hope people have recalled this. That is the corporate average fuel economy. So when I talk about the CAFE norm, in that case, I have told you that what the government will do, the government will take the average for all the vehicles, fuel economy, and then they will calculate a value. Okay, and then accordingly, they will give the benefits to the to the different corporates, or to the different companies. So in that case, what vehicles will come? In that case, we are having the petrol engines. We will be working on to the diesel engines in that case. Third will be CNG based engines, that is the engines which operate on compressed natural gas. And then we will be having hybrid vehicles. And then newly what we have added is, we have added the BEVs also, that is the battery electric vehicles. If the company is having these range of vehicles available, so government will take the average for the fuel economy over here, and then accordingly what they will do is, they will give the benefit to the corporate. Okay, so when they are talking about the hybrid vehicles also, so what they have done is, they have told the companies that they will not consider micro hybrid into this category. So when government means hybrid vehicles, they mean it can be mild hybrid, full hybrid, or it can be plug-in hybrid vehicle. I hope this thing is clear to all. When the government will take the will give the CAFE rating to the corporate, then in that case, they will not talk about the micro hybrid vehicle. So company cannot, if they're having the micro hybrid vehicle range, then company cannot claim that they're producing the hybrid vehicles. If the vehicle is micro hybrid vehicle, it will be considered either in the petrol segment or in the diesel segment itself. Okay, so because of these CAFE norms itself, the companies are planning to increase the production of either the battery electric vehicles or the full hybrid electric vehicles also. Okay, so how we can define the hybridization? It can be defined in four basic categories. The first is the micro hybrid. I hope people have heard about this micro hybrid. It has started coming from Mahindra Motors. Mahindra and Mahindra, they've introduced the micro hybrid system into the vehicles. Okay, that was the in Bolero, they are having micro hybrid. Bolero Neo, they are having the micro hybrid system. They've started giving the system from Scorpio. I hope people have seen that thing written at the labeling part also. That is Scorpio. They are having the M-Hawk engine series, and they have also written micro hybrid. Okay, so in India it has started coming from Mahindra and Mahindra itself. Then the second category is the mild hybrid vehicle. Then we are having the full hybrid vehicle, and then we are having the plug-in hybrid vehicles. Okay, now how we can classify these vehicles under these categories? So suppose the vehicle is having only start-stop system. The vehicle is having only start-stop system, then it will be only present in the micro hybrid vehicle. I hope this thing is clear to all. In Scorpio, what they have given is, they have given the micro hybrid technology, in which what they have done is, they have given the automatic start-stop. Automatic start-stop means, so suppose I've parked my car onto the signal, then Scorpio is the 4-cylinder engine. In that case, what will happen? So suppose I have parked my car onto the signal. The signal is more than 30 seconds. So it is always advised that what the consumer should do is, or what the driver should do is, that if he's seeing the signal which is more than 30 seconds, then in that case it is advisable to switch off the engine so that the fuel can be saved. Okay, but many of us don't. Even I don't do this, because in the case of the summer season, I want the continuous air conditioning system should be turned on. Okay. So we not do this. So keeping this in mind, the companies, they've started giving the start-stop systems. In the case of start-stop system, what will happen? That the two cylinders, they will not function. The fuel supply from the two cylinders, it will cut off. Only what will function now? Two cylinders out of four, they will be functioning, so that the air conditioning system can work. Okay. What will be the advantage of this? The advantage will be fuel saving. That is the first advantage. The advantage will be given to the driver who is driving the car. And second, when the fuel consumption will be less, then obviously the tailpipe emissions will be reduced. So this category, it comes under the micro hybrid, but micro hybrid category, it will not come under the CAFE. If the vehicle is micro hybrid vehicle, in that case, it will be considered either the petrol or the diesel vehicle. So in the case of, if I talk about the automatic start-stop switch, it is present in the micro hybrid system, it is present in the mild hybrid, it is present in full hybrid, and it is present in the plug-in hybrid also. Next is, if it uses a regenerative braking system and operates above 60 volts. So if there is a vehicle which is having regenerative braking system in place, and then it is operating the motor, it is operating more than 60 volts, then in that case, what will happen? It will be considered, it will be present in mild hybrid, it will be there in the full hybrid vehicles also, it will be there in the plug-in hybrid vehicles also. So generally what happens is, if I talk about mild, full and plug-in hybrid, then in that case, what actually happens, the vehicles are equipped with this regenerative braking system also, and majorly the motor which we are using, the motor is of 60 volts, or it can be 72 volts also. Next is, if it uses an electric motor to assist the combustion engine. It is present in all the categories. It is present in the mild hybrid also. It is present in the full hybrid system also. It is present in the plug-in hybrid system also. Next is, it can drive at times using only the electric motor. It means that now what we can do, so suppose I'm driving in the in city area where I do not have to accelerate the vehicle. In that case, what can happen? The engine can shut off and motor can do its work. So the system, it will come only in the full hybrid and the plug-in hybrid vehicle. Okay. Next comes, if I can recharge the battery, and recharging the battery option, it is only available in the plug-in hybrid system. Okay. So with the help of this, what we have done is, we have classified the vehicles according to the degree of hybridization which they are having. It can be micro, it can be mild, it can be full hybrid, or it can be plug-in hybrid. So what the companies are now focusing, on full hybrid vehicles and the plug-in hybrid vehicles. Though in India, we're not having any plug-in hybrid type vehicle available right now, but the companies, they're also focusing on this technology also. Okay, so till the time the infrastructure for the pure electric vehicles have not been developed, then in that case, the companies can now focus on this category of the vehicles also. And right now, Maruti Suzuki, they're having their hybrid vehicles in place. Okay, if I talk about Ertiga, so Ertiga is the hybrid vehicle. If I talk about Ciaz is also the hybrid vehicle. So first of all, this technology, it was implemented in Ciaz itself, and then it comes in S-Cross also. So the Nexa range of vehicles, they're having the this hybrid vehicle technology, and one arena based, that is Ertiga, that is also having this hybrid vehicle in place. Okay, so it is actually a full hybrid vehicle. It's actually a full hybrid vehicle in which the motor is assisting the engine as well. And second, if I'm driving in the lower speeds, then in that case, whole work can be done with the help of the motor also. Now, this is the HEV layout in which what we have done is we have classified the system into three types basically. If I talk about the hybrid electric vehicles, and three types of hybrid electric vehicles are there. First one is the series hybrid. The second model which we are having is the parallel hybrid. The third system which we are having is the series parallel hybrid. So three types of systems are available with us. That is the series hybrid system, parallel hybrid system, and the series parallel hybrid system. Okay, now in case of series hybrid system, what will happen? In case of series hybrid system, as the name suggests, that what will happen? We will be having only one power source available, which will be driving the vehicle. I've said that in the case of series hybrid vehicles, we will be having only one power source available, that star, which will be driving the vehicle. But as I'm telling you that it is the hybrid vehicles, in that case, what will be present? Two power sources will be there. That is, we'll be having the engine also, we will be having the motor also. But if I have to drive the wheels, so for driving the wheel, I'm only having one power source available with me. Okay, so what will happen? That the IC engine, it will give the drive to the generator. Generator will then recharge the battery, and from the battery the current will go into the motor, and from the motor it will pass on to the final drive, from which the vehicle can actually run. Okay, so this is the type of series hybrid vehicle in which we are having the IC engine in place, but the IC engine is only being used to drive the generator. The generator will produce the electricity for us. It will be stored into the batteries, and from the battery that current will be supplied into the electric motor, and then that electric motor, it will be driving the wheels. So that will be a type of series hybrid vehicles. And in case of series hybrid vehicles, generally what we are having is, we do not have the regenerative braking system, because that is not that much required. Because if I talk about the range of the series hybrid vehicles, the range is unlimited. What we have to do is, we have to fill the fuel into the fuel tank. From the fuel will go into the IC engine will run, it will turn on the generator, and then the current supply will be there into the motor, and vehicle will run. Okay, but here what we are having is, we are having major losses also, especially when the vehicle is going on to the higher altitude, then the availability of torque is very limited. So that is the basic disadvantage of having the series hybrid vehicle. So we're not using series hybrid vehicle anymore into the automotive industry. But yes, right now in the locomotives, locomotive means the train engines. In the case of train engines, what we are having is, we are having the series hybrid system itself. That the diesel locomotives, what we are having, the diesel locomotives, the diesel engine, it is only used to run the generator. And from the generator, the power is produced, which gives the drive to the motor. Okay, next comes the parallel hybrid system. So in case of parallel hybrid system, what will happen? In case of parallel hybrid system, we will be having two power sources. That is, we are having two power sources basically, the engine, second one is the motor. And in the case of parallel hybrid system, what we'll be having, that both these power sources will be working together. I hope you people are getting my point. In the case of parallel hybrid system, as I have told you, that we will be having two power sources available. The first power source will be engine. The second power source will be the motor, and both motor and engine, they will be working together. Now, you'll say that what will be the advantage for this? If both the power sources are working together, then what is the advantage of having the system? The advantage of having the system is that now the work will be divided. So suppose I'm driving in the city area. If I'm driving in the city area, suppose, then in that case, the work will be divided in both the power sources. If I'm driving in the city area, then in that case, the engine, it will give around 20-30% of the power required, and the remaining part will come from motor. If I'm driving onto the highways, then in that case, 80% power will come from the engine and 20% power will come from the motor. That is, the motor will be assisting the engine for producing the power. In case of third category, what can happen? Suppose more power is required. I'm climbing the I'm driving the vehicles on very higher altitudes. Then in that case, more power is required. Then in that case, the motor will give full assistance to the engine so that the vehicle can go up to the higher altitude. This will be the example of parallel hybrid system. Okay, so these systems, they are used in certain generation of cars. Okay, and the Cadillac, it is the example of this parallel hybrid system itself. Next comes the series parallel hybrid system. Next comes the series parallel hybrid system, which is being vastly used by majority of the companies, which will give the advantage of both series hybrid and the parallel hybrid. Now, what will happen in the system? That is, if I'm driving, suppose if I'm driving in the city area, I do not want my engine to work because the cruising speed is less. And in that case, I do not want the power to come out from the engine. So engine can be in off condition, or it can be at the idle condition. So in that case, all the power requirement will come from electric motor itself. If I'm driving in the higher speed ranges, then in that case, what can happen? In that case, the engine, the drive can be shifted towards the engine, and engine will supply all the necessary power for the cruising of the vehicle. If I'm driving in the higher altitudes, or if I require more power, then in that case, both engine and motor, they can run together for giving the power. This will be the added advantage with the series parallel hybrid system. Okay, that is, alone IC engine can give the drive to the vehicle, alone motor can give the drive to the electric vehicle, or both together can give the drive to the electric vehicle. So for that, what we are having is, we are having the clutches involved. Okay, so how these clutches will be there? So first of all, we are having the engine, and with the engine, we are having the motor, then we are having the another clutch, and then we are having the transmission system. So this is C1, that is clutch 1. This is C2, that is clutch 2. So with the help of a power split device over here, what will happen? The power split device is nothing but it is the microprocessor which will be calculating the requirement of the power sources. Accordingly, what will happen? The power split device, it will actuate either the engine, it will actuate either the electric motor, or it can actuate both the two also. Okay, and if I talk about the fuel efficiency, then around 28 to 30% fuel savings are there with the help of series parallel hybrid system. If I talk about the series hybrid system, then in the case of series hybrid system, the fuel saving, it goes to 60 to 70%. Why 60 to 70%? Because in this case, I can use the smaller engine which can produce the power for me. Because the engine has not engine do not have to drive the vehicle. So in that case, engine is only the part which is actually running the generator. Okay, so we will be having 60 to 70% of fuel saving, but we are having major disadvantages also. Okay, the major disadvantage is, suppose I have to climb onto the higher altitude, or if the load onto the vehicle is less, then in that case, big size motor is required. And for the big size motor, we require the bigger battery pack. So that is the basic disadvantage of the series hybrid system. If I talk about the parallel hybrid system, so in the case of parallel hybrid system, the fuel saving of 10 to 15% is achieved. Okay, but with the help of series parallel hybrid system, we can get the fuel savings of near about 28 to 30%. Why? The major reason behind that is, according to the requirement, the power source can be switched. Okay, so this is the layout for the hybrid electric vehicles. What are the major components? As I have told you, that we'll be having a battery. So that will not be an ordinary battery pack. It will not be a general lead acid battery we are having. It will be a lighter battery pack installed, and that will be lithium-ion battery pack. And the lifespan for that lithium-ion battery pack is near about 10 years, which the company actually claims. Next part is the generator, which will produce the electrical current. Then there will be the motor, which will actually propel the vehicle. Okay, so these will be the components for the HEV battery system. Now, this this energy loss I've taken from the study being conducted by MIT, that is Massachusetts Institute of Technology. So in that, what they have done is they have conducted the study that how much amount of energy loss is actually happening. Okay, so we have compared this with the IC engine based vehicles to the hybrid electric vehicles or fully electric vehicles. So in that case, if I'm talking in that, they have taken the Toyota Camry for performing their experiments. Okay, then they have driven the vehicle in city area, in the highway area, and then they have found out that how much power is actually coming onto the wheels. That is the major problem. If I talk about the IC engine based vehicles, and in the case of IC engine based vehicles, the efficiency of engine is very less, and accordingly the power produced is also less. Okay, so from the fuel tank, 100% of fuel is going onto the engine. So engine is producing 100% power. What is producing? Engine is producing 100% power. That is near about whole amount of air and fuel mixture will get burned. But in the engine itself, what will happen? Certain losses will be there. The major loss can be engine loss. So what will be coming under the engine loss? Engine loss will be thermal losses. If I'm talking about the engine loss, then it can be thermal loss. Thermal loss means that when we are driving the vehicle with the engine, then in the engine, what we are having a dedicated cooling system also. So cooling system, it also takes certain level of heat from the engine, which actually comes under the loss itself. Then we are having the blow-by losses also. That is some part of fresh fuel. It also goes with the exhaust gases also. Then we have got the pumping losses also. Pumping loss means, so these are the three types of loss actually which happens in the engine. Thermal losses, that is the loss which happens because of the cooling system of the vehicle. Next will be the blow-by losses, which happens because of the blow-by, because we have to make the proper ventilation also available. Next will be the pumping losses. What are the pumping losses? That in the case of IC engines, especially in the case of 4-stroke IC engines, what we are getting is we are getting the power only in one stroke. That is the power stroke. In all the remaining strokes, what we have to do is, when piston has to move on its own, so we have to store some amount of energy into the flywheel also. So that is the pumping losses. So these losses contribute near about 76%. Okay, and there are certain standby losses also, so that contributes near about 8%. So what is coming out from the engine is 16% power is coming out from the engine. We have combusted whole amount of fuel, and out of which only what we are getting 16% only. Now this 16% will be passed on to the drive line. So in the drive line also, because of the friction, certain losses will be there. That accounts near about 3%. So what is available at the driving side? The driving side, what we've got is we have got only 13% of power produced by the engine, which will be responsible for driving the vehicle. And in that also, what we're having certain losses. Okay, because of which the fuel efficiency of the vehicle can be varied. So accordingly, what happens is the engine has to produce. If engine has to produce more power, it has to burn more amount of fuel. Now, this is for the city losses. In the case of city, the losses are very high. But if I talk about the highway driving, in the case of highway driving, what we're having is we're only having the engine losses. Standby losses are not there, because if I'm cruising in the higher speeds, and obviously I'll not park the vehicle somewhere and my engine will not be in the idling condition. So there will be no standby for the engine. So what I've done is we have not considered standby losses over here. So what is available? 23% of power is available with us. But when we are cruising with the higher speeds, and driveline losses will a little bit increase. And what is available with the wheels is we are left with the 19% of the total generated power available, which is responsible for driving the vehicle. Now if I've got the hybrid system available, then what will be the advantage over here? How I can save the energy? That is, from the fuel tank, 100% of fuel will come. It will go on to the engine where the fuel and air, it will get burned. If I talk about, first of all, if I talk about the standby losses, that standby losses means idle losses. So if I talk about those idle losses, if the vehicle is having a start-stop system, there's a vehicle which is having a start-stop system. So in that case, that is the micro hybrid system. So in that case, actually what will happen, the standby losses, it will become zero. It will be eliminated. Next, if I talk about the engine losses, then in the engine losses, what we are having is, if I'm having the full hybrid system, then in that case, we have downsized the engine. So downsizing the engine means that the losses can be recovered. Next, decoupling of engine and wheel feature is available, and that is available in the series parallel hybrid systems, where as per the requirement, we can switch onto the electric vehicle or onto the engine vehicle. Okay, and if I'm having the plug-in electric vehicle, and in that case, what can happen? These losses can be made near to zero also. Plug-in hybrid system means that we are having the dedicated battery pack available, with the help of which what we can do is we can propel the vehicle. Okay, and once the once the battery it has got discharged, then obviously what we can do is we can switch on to the engine mode itself. So next time when I will park the car, in that case I can charge the battery pack available. So that is the plug-in hybrid vehicle. So with the help of that, what we have done is we have reduced the losses. So that is the basic advantage of having the hybrid vehicles in place. That is the basic advantage of having the hybrid vehicles in place. And this hybrid vehicle, it is not only reducing these losses, it is actually also reducing the tailpipe emissions also. Okay. If I talk about the braking losses also, that accounts 6% of it. In that case, actually what will happen? In that case, if I'm having the mild hybrid system, full hybrid system, or the plug-in hybrid system, or if I'm having the battery electric vehicles, in that case, we're having the regenerative braking systems. So with the help of which, what we can do is we can reduce the braking losses also, because what we can do with that system is we can convert the kinetic energy into the electrical energy. In that case, motor, it turns into the generator itself. And with the help of back EMF produced by the motor, the brakes are also introduced. Now, if I talk about the city driving for the electric vehicles, and we are having the batteries which are 100% charged, giving current to the motor. And in that case, motor losses near about 10%, because in the motors also we are having certain rotating components which account certain losses. 90% of power is transmitted to the drive line, and in the drive line we are also certain we've got certain losses available, and that is 14% of the losses are present, and then 76% of the total power, it has been available with the wheels, with the help of which the vehicle can propel. Now this is the efficiency from from well to tank, actually. That is from the point where the power is produced to the point where the where that produced power will be utilized. So I've taken two examples over here, conventional vehicles versus electric vehicles. First of all, if I talk about the electric vehicles, in the electric vehicles, first of all, what we have to do is we have to generate the power at a particular source, and then from that source the power will be transmitted. So we are having certain transmission losses also. Okay, so it contributes near about 85 to 90% of power is available. Okay, 10 to 15% is actually wasted. Then in that case, we are supplying it to the various households where certain losses will be there. Then in that case, if I'm having the full electric vehicle, then in that case, from plug to wheels, what we're having is 76% power available, 23% it is wasted. The 76% of the power it is available in the case of electric vehicles also. considering all the losses, which have, the losses which has occurred from the power production zone to the transmission zone. Next comes the conventional vehicles, in which we do the refining process. Then after the refining process is over, we transfer the fuel in the either in the pipes or with the help of the tankers from one place to another. Now in those tankers also certain losses are there, because if I talk about the petrol, which is highly volatile, which is highly volatile, then in that case what will happen, the losses will be more, because of the evaporation of the petrol, certain amount of fuel, it will be evaporated, and thus the losses will be more. And then when it will come into the vehicle, then obviously what will happen, only 13% of the power it will be available at the vehicle, at the wheel side, which will be helpful in driving the vehicles. Next comes the EPA rating. EPA stands for Environmental Protection Agency. So this EPA, what it do is it gives the rating. So once the test procedures are followed, accordingly what they will do is they will give the rating to the vehicle. Okay, so that is known as EPA rating. Right now, if I talk about the conventional vehicles, so the conventional vehicles, they have to be certified from either ICAT, ARAI, or GARC. These are the testing agencies. ICAT is located in Manesar, that is International Center for Advanced Automotive Technology. Next comes the ARAI, that is located in Pune, Automotive Research Association of India. Third comes your GARC, that is Global Automotive Research Center, which is located in Chennai. So either from these three, the company has to obtain a certificate where all the test procedures will be followed, and accordingly the vehicle will be certified. And once the certification is achieved, then in that case it can be launched into the market. Similarly, with the help of electric vehicles or the battery electric vehicles, apart from getting the ratings or certifications from these agencies, they need to also get the rating from the EPA also, that is the Environmental Protection Agency also, where they will test the vehicles according to the drive cycle. That is, they are driving, the vehicle is either driven city area, highway cycle, or constant speed cycle. Then they will test the temperature. Test temperature will be what they will do is they will increase the temperature, and accordingly they will find out that what is the effect onto the battery or onto the efficiency of the vehicle. Then they will test it onto the start system. They will start the vehicle. They will give the warm start also. They will give the cold start also. They will test it with the fuel, because if I'm having the hybrid vehicle in place, then in that case the fuel test will also be covered. So accordingly, what will be given? The EPA rating will be given, and according to the EPA rating, the test certifications will be given by these three agencies, and the vehicle can be launched into the market. Okay, right now if I'm talking about the Indian automotive, and in that case, the vehicles, the full electric vehicles which we are having and the hybrid electric vehicles which we are having, they're getting the reports directly from the ICAT, ARAI, or GARC. Okay, and there itself they're getting this EPA rating also. Now, certain terminologies are there. People all know about these terminologies. The first one is the state of charge. That is the maximum capacity of a battery. Depth of discharge. That is by how much proportion or by how much amount the battery can be discharged. Next comes the capacity of a battery. That is the charge storing capacity of battery, which is known as AH. That is the ampere hour rating. Next comes the energy. So energy is nothing. It is the total watt hour available when the battery is discharged at the specific current from 100% SOC. SOC means state of charge. So suppose we are having 12-volt battery. So what we will do is we will discharge the battery. According to the test conditions, what we will do is we will discharge the battery, and accordingly we will give the rating to the battery. Next comes the specific energy. Specific energy, it is the watt hour per unit mass. Next comes the specific power, the maximum power which can be produced per unit mass. That will be known as the specific power, which will be given onto the battery term. So these terminologies, they're all related to the batteries itself. Now, if I talk about the benefits of electric vehicles and the plug-in hybrid vehicles, the benefits are it is more efficient, fuel costs lower down, lower emissions. Next comes the simpler transmissions and the few moving parts. We have decreased the moving parts also. We've got the fuel choice available. If I talk about the hybrid vehicles or the plug-in hybrid vehicles, in that case, we have got the fuel choice available. Either we can drive onto the electric mode or we can drive onto the ICE engine mode also. Oil or energy independence. If I'm talking about pure electric vehicle, in that case, we've got full independence from the oil or gas. We do not have to fill the oil or gas into the engine because there's no engine placed over there. Okay, only what I have to do in the case of EVs is we have to charge the battery. Emissions, they have been reduced. Okay, so with the help, these are the certain benefits of the electric vehicles and the plug-in hybrid vehicles in comparison with the ICE engine based vehicles. Next important thing which will be coming is that is the vehicle to grid technology. That will be the newer thing which will be coming, though it has not been introduced right now. But in the in the future, this technology will also be there. That is the vehicle to grid technology. Now, what will be the vehicle to grid technology? The vehicle to grid technology, it means that suppose what I've done is I've got the 40-kilometer range of the vehicle. It means that from my home, my office is 20 kilometers. I'm having an electric vehicle in place. Okay. Now, I've taken my vehicle from my home to the office. That is 20 kilometers. Generally, in the offices also, what is present, the charging points are present where I can charge the where I can charge the vehicle. So in that case, what I have done is I've taken my car to the office. I've parked my car, and accordingly, what I've done is I've I've plugged in the charger. My battery is now 100% charged. Again, what I'm doing is I'm driving my vehicle back from office to my home. That is only 20 kilometers. That is sufficient amount of electric current is present into the batteries. So what I can do is with this vehicle to grid interaction technology, what I can do is I can give the excess amount of power which is available with the battery to the grid also. That is, I can earn money also with that. If I'm having excess amount of this charge available, then with the help of this vehicle to grid interaction, what we can do is we can actually connect with the vehicle with the grid, and we can supply the excess charge to the grid also. And accordingly, what will happen? The government, it will make the compensation part also. Though right now it is not there, but in near future, it will also be coming into the market. Okay, but before this vehicle to grid technology will come, what we have to do is we have to make our grid smart also. Right now, the grid is pure mechanical. Then what we have to do is we have to make our grid smart. Smart means that the grid has to be controlled with the help of the microprocessors and all. So this is the CO2 emissions. You can see that the electric car is having less amount of carbon dioxide emissions. Why only 10.5? I have written 10.6 over here. The reason behind that is in the case of electric vehicles also, they have got the braking system. So when I talk about the braking system, so certain level of pollution also comes from the braking system as well. That is why the electric vehicles, they're not actually 0% polluting car. It actually makes the pollution, but it is very negligible. Then if it comes to the hybrid electric vehicles, then obviously the level of pollution will be slightly higher. Why? Because in that case, what will happen? The ICE engine will be placed. Though the ICE engine will be of smaller size. So smaller size ICE engine means the smaller amount or less amount of pollution will be produced. If I talk about the conventional vehicles, then obviously from the conventional vehicles, the level of pollution will be very high, because according to the size of the vehicle, what we have to do is we have to design the engine also. So suppose I'm having a car that is Fortuner. I cannot drive the Fortuner with Maruti 800 engine. For that, I require 3-liter engine to drive the vehicle. So for 3 liter, it means big size engine, which will accumulate more amount of air and fuel mixture into it, and thus the pollution produced by that vehicle will also be. What are the challenges? The first challenge is the limited range, long charging time, high initial cost, battery life, that is the basic problem, consumer acceptance, that is the basic problem right now, but yes, I'm definitely sure that in near future it will increase. Consumers, they will accept the electric vehicles also. Okay, generally, if I see in the metro cities, the number of electric vehicles are more onto the roads if I'm comparing it with the non-metro cities. Because suppose if I talk about two cities, I'm living in Delhi and I work in Gurgaon. I'm living in Delhi, I'm working in Gurgaon, then obviously from Delhi to Gurgaon, it hardly takes, it is hardly around 35-40 kilometers. So for that 35-40 kilometers, and there is heavy traffic also. And right now, as the cost of fuel is very high, and in that case, obviously the operating cost for my conventional IC engine based vehicle will be very high. So people over there, they are switching on to the electric vehicles, and where they are saving, uh, huge amount of money with the help of these electric vehicles in place. The penetration of Tata Nexon EV is very much high in Delhi NCR region. Even if the people is commuting from Delhi to Meerut, which is actually 60 kilometers of distance, the people they are using electric car over there. Why? Because Nexon, it is giving the very decent range with the single charge. It comes near about 300 kilometers per single charge, and right now they have increased up to 400 kilometers also. Okay, but yes, the customer, they will take certain time to accept the change. Okay, and then once that time frame will come, then obviously the demand of EVs, they will also increase. Next is the grid integration. That is this that is the uh, charging infrastructure available onto the roads, and this smart grid technology which has to come uh, for the support of this electric vehicles. Now, how can we meet the challenge? The first one can be battery swapping. Or we can have the fast charging option available. Okay, the government right now they're drafting a policy for battery swapping also. Battery swapping means that first of all, for the battery swapping, what should happen, that all the companies, they must produce the batteries of of uniform size, so that the batteries can be interchanged. Now, what will be the battery swapping? Suppose I'm having a car. My car's battery is discharged, and in that case, I'll go on to the charging station where the charged batteries will be available. And in that case, what they will do is they will just swap the battery. They will take out my discharged battery and they will install the uh, charged battery into it, which will hardly take 10 to 15 minutes of time. It is available in certain countries. In USA, it is available. Though battery swapping for electric passenger cars are not available over there, but the battery swapping for the two-wheelers are available. They've got the definite charging points where the person can come, he or she, what they can do is they can remove the battery from the vehicle and just put it onto the charging, and they can take the charged battery from there. But it has certain cost. By paying that cost, the battery swapping can be done. So that is the if battery swapping policy will be passed, then obviously it will be the big relief for the electrical vehicle consumers. Because for commuting from one place to another, which is 500 kilometers, the specific range is not available, and for the charging, they have to wait for, if they have to wait for 1.5 hours, then obviously it will be very tiring. You know. Journey for the commuters. And in that case, the battery swapping, it will place the it will actually give the very important role into it. Next can be the fast charging. So within the fraction of time, 10 to 15 minutes, the battery can be 100% charged. So for that, we require huge amount of DC current. Plus fast charging, it also deteriorates the battery. So if we are working onto this technology also, in which the vehicle can be charged in certain minutes itself. Next can be the change in the battery materials. The battery materials can be changed, which will gradually reduce the cost of the battery. Right now, we are dependent onto the lithium battery pack itself. So we have to import the lithium. Importing the lithium means heavy import duties, and thus dependency onto the other countries means that the regular supply for the raw material should be there. So that is why the cost right now for the lithium battery is very high. But yes, near future, the cost will reduce when newer battery materials will be coming for the electric vehicles or the hybrid vehicle technology. Obviously, we have increased the life of battery. Earlier, the life of pure lithium-ion battery, it was near about 5 years. But now companies are giving 7 years warranty onto the lithium-ion battery pack also. Actually, right now it is LiFePO4, that is lithium iron phosphate ion battery. They're using LiFePO4 batteries in some cases, which is having the higher lifespan of 7 years. And right now, Tata Motors, what they have claimed is they are saying that they will give the batteries having the life of 10 years also. Okay, and in the case of electric vehicles, the major cost, that is for the battery pack itself, around 60-65% of the cost, it is related to the battery pack itself. Now you can see the curve also. In 2006, the cost of battery was very high, but right now, gradually over certain times over here, what has actually happened? The cost has decreased, and there will be further decrement in this cost also. It's not like that the cost will increase; the cost will reduce. When the cost will reduce, when the newer battery materials will be used for constructing our battery. Okay, so this is all from my side about the alternative drives to the vehicles.